We would like to welcome you to this seminar at STAMI. A special welcome to all of you following us online. My name is Lund. I work here at STAMI and I am responsible for the practical organization of this day. So therefore, I will start to give you some practical information. If the fire alarm goes off, please go out the door you came in. Everyone goes to the back side of the building, where you can see a green field. And we will gather at this field, and I will count everyone and make sure that no one is left inside. I will also make you aware that there is an emergency exit in the upper corner, the green door. The seminar will be streamed live, and it will be available it will be published on stami.no. And we will have 2 breaks during this seminar, and there will be some snacks available in each break. So that was the practical information so far. Now I'll give the microphone to my colleague Shan, who will introduce himself and tell you more about the program for today.
Do you have it on the screen, the program? Yes, and my name is Shan Zienolddiny, and I'm forskningschef here at STAMI, or in English it is called Lead Research Professor. It's very good. And I'm glad to see many of you, and we have set up at least we believe that it's a very interesting program, as you can see it. And so the program starts with Dr. Paul Molander, who is our Director General. And I think I will make it short. And the themes, you can see them after Paul. I will present the guidelines, and then Dr. Astrid Lund Ramstad from Arbeidstilsynet will present her thoughts. And then we have Dr. Vladimir Murashov, who has come here from United States to talk about the guidelines. And then at the end we will have a session with questions and answers. So we have done it like this, that I think we will wait with all questions unless there is something really burning and you cannot wait. So you can ask us at the end of each presentation. So we welcome you all, and we hope that you will find this seminar interesting and enjoy it. So I invite Dr. Paul Molander, our Director General.
Thank you. We are very glad that we have the possibility to give this seminar, because Shan and his colleagues has been working quite intensively for some years actually, with a review, a systematic review on the impact on engineered nanoparticles, manufactured nanoparticles on workers' health, which is an important topic. And we were given this assignment by the World Health Organization, WHO, which has a special department, a special activity on workers' health. And there are 55 collaborating centers all around the world who are collaborating on contributions to this field in occupational health, and STAMI are one of those. We are 2 collaborating centers in the Nordic region, I believe. It's STAMI and it's the Finnish Institute of Occupational Health. So Shan and STAMI were given the responsibility to carry out this systematic review along with Vidar Skau and Benedicte Mohr. And they have been publishing this review both through the WHO system, but also in an international referee-based journal as well in last year. So we know at this stage we have a better knowledge about the state of the art on engineered nanoparticles, on workers' health. And we know what we know, and we also know a little bit about what we don't know, which actually points in a direction on further research and further knowledge transfer to the enterprises who are working with these issues. In Norway today, we have increased interest in work environment. Actually, we have just had a new agreement on inclusive work life, where it's been a tremendous increment in focus on work environment on the big issues in the Norwegian society related to the work life. And in that regard, I think it's very important that we also have our eyes on the aspects of chemicals and chemical exposures in the work life. Many people refer to chemical exposures as old exposures. Actually, it's not that relevant anymore. It don't contribute to sickness absence and all those things that are a cost on the state budget, they claim. But that's not true. Actually, we are in a phase where we are more and more obligated to have innovation in Norway. And one of the places that we have very much innovation is in all those branches where they use chemicals. For instance, with new materials, in the energy sector, in biotech, etc. So we have a lot of innovation related to chemicals, and it's increasing, not only in Norway, but in the rest of the world. So to refer to chemical exposures in general, which actually nanomaterials is a part of that big family, it's to refer to that as old exposure, that is completely wrong. It's new, it's modern, and it's innovation. So we need better knowledge on these topics, and especially on the new materials that are increasing a lot in use, and also in Norway, where we see an increment in this field. So we need much more knowledge in the years to come. But at this stage, we have summed up the knowledge that we have so far, based on the international scientific reviewed literature. And that is the topic that you're going to hear about today. Shan is going to give an introduction to the review, and we are going to have some thoughts by the Labour Inspectorate on what impact this will have on the regulation issues, and also on the labour inspection activities. And not at least, we are very happy to have Dr. Vladimir Murashov from NIOSH, the National Institute of Occupational Safety and Health in the USS, which is among the best known and with the best reputation institutes in the occupational health field. And he is in charge of all the reviews in WHO, and so he represents also WHO, and he is going to give us information on those topics, and also especially on this specific review. So we are very glad that we have such an international, well-known scientist also to give us information on that regard. So then it's left for me to thank you all for coming. It's very important that we have all these knowledge brought out and made accessible to the Norwegian work life, in order to have prevention for new risks in the work life. That is basically why STAMI is working, and that is basically why we have a lot of impact on occupational safety and health issues in the Norwegian work life. So I wish you all a very nice seminar, and hope that you will have a fruitful day. Then I give the word to Shan. Thank you.
Thank you, Paul.
Thank you. With this, I think we start our hearing. It's not too loud. So Paul was kind enough, and he gave us, 5 minutes more. So that's good. Yes, and the today's seminar is on the WHO guidelines on protecting workers from potential risks of manufactured. As I said, so I have been working some years here at STAMI on this topic. And then what I'm going to do is I'm going to give you a background information on nanomaterials, and where I will go through the topics, nanomaterials, their applications, and of course we are concerned about the occupational health concerns. So I will dedicate some good time, on this topic before I go to the second part, which is a presentation of the WHO guidelines document, and where I will touch upon the key issues and questions that were asked, or were the basis of the guidelines, and the answers to the questions in form of, which came out in form of best practices and specific recommendations. And as I mentioned before, Dr. Murashov was the head of that the steering group who worked with this guideline. So we are very happy to have him here. And the reason that we are talking English today, we know that the audience are, I think most of them are Norwegian, but we do it in English just to so that Vladimir can understand better what we are saying, and then he will have a chance, to at the end of the seminar for the questions and answers. Okay, so what is a nanomaterial, or the nanoscale? We are talking about nanoscale, and so when we are talking about nanoscales, we are talking mostly about the materials that they have at least one dimension in nanoscale. And nanoscale, traditionally, it's not, decided. Nobody has decided how to define the nanoscale, but traditionally they are defined as the scale between, or materials between 1 and 100 nanometers, as it is shown here. You have the scale of this, which is on metric, and it is on nanometer the scale is. And you can see it how small a nanometer is. And to just give you some idea, to imagine how small is a nanomaterial, or a nanoscale, material. So a human hair, as it is shown there, it is about 50 to 100,000 nanometer, and but of course it depends upon the type of hair and the color of hair. My hair maybe is thicker, so with the age you get thicker, and the hair gets thicker. And also you have a sheet of paper, for example, it's 75,000. If you have a sheet of paper in your hand, it's 75,000 nanometer. So for the other scales, you have the red blood cells, which are 7,000 nanometers in diameter. And you have the DNA, which is the diameter is 2.5 nanometer. And then you just imagine that the nanomaterials are very, really small, or the hydrogen atom is 0.7 nanometer. If you put 10 hydrogen atoms, then it becomes 7 nanometers. So you can see that how small they are. So they are very small things we are dealing with. I will come back with a more specific definition for the nanomaterials for regulatory aspects. This is just a general idea what we think about that. Because you have to define them more specifically, in order to be able to handle them in the regulation. So when we are talking about the nanoscale, we know that size changes the property of materials. For example, color of a material changes with the size of the material. It means that downsizing changes, the properties of the materials. The picture on the upper panel, you can see it. You can recognize it. We like it very much. It is gold, very precious, metal. So on the upper panel, it shows that the color of gold, the bulk material is bright, shiny, and yellowish. But when the size is downsized to micron, it becomes more, in micron, it becomes reddish, and the further reduction, as you can see it on the upper panel in the last picture, depending on the particle size, it becomes, green or blue. That I was not imagining that gold could be, blue or something like that. On the lower panel, you can see that this is the titanium dioxide and zinc oxide. It's on Norwegian written as well there. And you see the different sizes that they will change, the color. These are these properties that are used, in sunscreens, so that the cream is not really visible. So as you can see, as you downsize the titanium dioxide or zinc oxide, the color, disappears, or it becomes, more or less colorless. So this is very good property. And also you can see it's on the lower right panel, you can see the quantum dots according to this, size of the particles. So they will have different, colors. So with reduction of size, many other physical and chemical properties, not only color, such as surface area, reactivity, melting and boiling points, conductivity, magnetism, all are changed. So these are very good properties, and would be very advantageous in somehow. And here is, downsizing. The other property of the nanomaterials is that if you don't downsize them, then the surface area changes, and it becomes really very huge. This means that if we compare the surface area of 1 gram of bulk gold, you can see it on the left, the first figure. In nanoform, the surface area of the nanogold will extremely change and be high. And you can see it is the same amount or the same amount of the gold on the left, but on the right, the surface area will be different. You can see the surface area has increased now 4 times from if you have 1 by 1 cube gold. So increased surface area leads to exposure of more and more inner atoms to the surface, and therefore increases their surface reactivity, which is both beneficial from a material point of view, but could be harmful from a health hazard perspective. As I will show you an example later on with rat lung and an example on how the materials, which are very small, they will be distributed in the rat lung. So the property changes offer very interesting opportunities for material scientists to exploit and manufacture materials at nanosize or nanocomposites with novel properties and applications. And it's these properties which are used by a technology which is called nanotechnology, and manufactured, the so-called manufactured nanomaterials. And these manufactured nanomaterials are also called engineered nanomaterials. They have maybe other names as well, but the term which is used in these guidelines, it is used manufactured nanomaterials, M&M. But you can also say ENM and so on. So one thing is that these are these nanomaterials, and as I said, this general thinking and about the nanomaterials. The other thing is that when they are manufactured, so you should have a kind of definition for these nanomaterials to handle them in the regulation. That's why the EU Commission has come up with a definition, or it is a recommendation. This definition is just important to emphasize that it is a recommendation. In 2011, the Commission, EC Commission, adopted a definition, which I'm going to present it to you. And they were saying that a nanomaterial means a natural, incidental, or manufactured material containing particles in an unbound state, or as an aggregate, or as an agglomerate, and where for 50% or more of the particles in the number size distribution, one or more external emissions is in the size range 1 nanometer to 100 nanometer. So as I was saying, that it is traditional to say 1 and to 1 nanometer, but we have a regulatory recommendation from EC saying that it is the materials between 1 and 100 nanometer should be considered, a nanomaterial. But nevertheless, pay attention that this recommendation is not dealing only with the manufactured nanomaterials. They are also talking about the natural ones, or incidental ones. So, and then they say that in specific cases, and where warranted by concerns for the environment, health, safety, or competitiveness, the number size distribution threshold of 50% may be replaced by threshold between 1 and 50%. So it's a complex matter. It's not, really so straightforward, to say which material is nanomaterial and which is not. So there is so many things that to consider here. And again, by derogation, fullerenes, graphene flakes, and single-wall carbon nanotubes with 1 or more external dimensions below 1 nanometer. So now we are talking about exceptions here, those which are below 1 nanometer. We were talking about between 1 and 100 nanometer should be considered as nanomaterials, because some of these, carbonaceous materials can have dimensions below 1 nanometer. And we have had carbon nanotubes here testing for testing purposes that they have 0.30 nanometer as diameter. So one thing is not often talked in the scientific committee or other is not presented, which I have marked here on, is it gold or is orange, whatever color, is that there is still another thing, is that where technically feasible and requested in specific legislation, blah, 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 a material where the specific surface area by volume of the material is greater than 60 square meter per cubic centimeter is also a nanomaterial. So, this definition is really complicated. And I know that the industry and other, and even regulatory bodies, they have kind of, really they have to make huge efforts, to get this definition and how it matches in for their requirements. However, in 2019, this year, the EU published a report that aims to provide clarifications of the key concepts and terms that are used in the EC/NM definition and discusses them in a regulatory context. I show you this link, and I hope that you can try and see what are the clarifications. So many details are there. And one thing is that it was supposed that definition should be revised, and I think it has been postponed until 2020. I think Astrid may know it better than me, but I think it has been postponed until 2020. I don't know why, but you can just imagine. So it's not really easy, So they have made a kind of clarifications, which I have listed here. So, that the EC nanomaterial definition, this is some extracts from that new clarification document from the EC. It limits the scope of the term nanomaterial to materials containing or consisting of particles. particulate materials or particles, particulate materials. It's not a definition of nanostructures. Again, so I mean, something that really needs, some thoughts about that. The term particle is defined as a minute piece of matter with defined physical boundaries. So there are some definitions of particles, what they mean, what are the agglomerates, and so on. You can have a look on the document. I have put the link on below that. So the grains do not fall in the scope of the ECNM definition. Such materials may be used as a basis for the preparation of nanomaterials by milling or grinding and so on. The term nanomaterial doesn't cover single molecules. Still, again, another, exception, with the exception of fluorines, graphene, and single-walled carbon nanotubes. This exclusion doesn't explicitly appear in the text of the ECNM definition, but it is on this, qualifications document. So have a look on that. The link is there. And we just tried, me and Vladimir, that some links may not work. So we will see. Just contact us. We will give you the right links if they are not working. So nanomaterials are made from various materials. And as you can see, the term is used, the engineered nanomaterials. I mean, this is two groups, but there are many other materials, other particle types that are made. As I say, the nanotechnology is really a key and enabling technology. They are making, particles and materials from everything you can imagine. There is no limit. I think there is no limit at all. So here, organic materials like carbonaceous materials, carbon nanotubes, fluorines, as I was mentioning. And then you have different types of the fluorines, C60, C17, with different structures. You have carbon nanotubes which are made of single-walled and multiple-walled, double-walled, and so on. And you have this inorganic, which could be metal oxides like zinc oxide, cerium oxide, and so on. You have see the pictures, some of them there. Metals from gold, as I was mentioning there, silver, and you have the quantum dots which are kind of a combination of the organic and inorganic materials. Like, you have the cadmium core or metal core, and so you have covered by other things. Cadmium, dots that I was showing a picture, so it was there. As I mentioned earlier, manufactured nanomaterials are made by nanotechnology, which is really a key and enabling technology. And there has been kind of, huge efforts both nationally in Norway by the Norwegian Research Council and the EU research fundings that have funded this technology to develop further. And these materials are made for almost all applications, as you can see it on the left panel. So they can be made for energy storage, defense and security, metallurgy and other materials, electronics, optical engineering, communication, biomedical and drug delivery is a very important, field. And I will show you some examples there. Agriculture and food is also an important, field there that I will show you some examples. Cosmetics, of course, they are very important because most of all us, using them. And the other biotechnological, processes, textiles are also important, materials that are used. So as you can see, that nanotechnology is making a great contribution to the economy. And this is, you can see it from 2015 to 2019. It has been almost a doubling of the contribution of the nanotechnology to the economy. I think this is globally. And as you can see, it is $80 billion in 2019. So the list of products includes very simple consumer products, like, I mean, you can see it here, sunscreens on the left, cosmetics, and you can see the socks, the trousers, and textiles. And the other thing is, you know, I think it's making also some progress in the building or the construction field, where you have this, you know, self-cleaning glasses. That is good, you know, for the occupational health, because the workers don't need, you know, to climb to these, you know, high buildings, and then you really avoid, you know, many of these, you know, accidents and injuries. So that's very good. And even I like, you know, this self-cleaning windows at my home. I don't need, you know, to go outside and you clean my window, you know, when it's -20. And you have these, you know, nano paints and so on, which are really very good, and they have a kind of mold and bacterial resistant properties. So it's very nice and very good, and it's helping. The other thing, as I say, is that nanomedicine, which is application of nanotechnology in medicine, is a growing field. Nanoparticles are used both as nanodrugs as well as nanomedical devices. An example of a nanomedical device is a CNT, which is shown here, which is used as a drug carrier and reservoir. So, as shown in the upper panel, drug solution, in this case, an anti-inflammatory drug, dexamethasone, is filled into the interior of the CNT, as you can see it on the upper panel. And then in the lower panel, you can see the drug is released from CNT reservoir to surroundings through diffusion or electric stimulation. I should mention that we STAMI, we are so fortunate that we are part of an EU Horizon 2020 project that are developing, you know, these nanomedical devices. And we were arguing that we should include the worker safety in the beginning while they are being developed. So I was in that kickoff meeting for that project, and we will look forward and to see, because really nanomedicine is doing a lot, or nanomedicine is being very important, you know, in biomedical sciences. And here is some FDA approved cancer therapeutics, as you can see them. And also a new review by another group in 2017. They identified 43 approved nanopharmaceuticals, which includes both nanomedicines and nanomedical devices globally. And some were approved in China and South Korea. I'm not going to go through this table, but you can see that there are so many problems with, I mean, usual or classic drugs that can be solved with these nanomedicines. And some of them are like, I mean, drug toxicity and adverse, you know, cardiac effects, which may be side effects of some of the classical drugs that can be solved by these, you know, devices. So they are making a kind of, you know, very good progress in this field, making very effective drugs and nanomedical devices. So the other thing is that we know that bacterial resistance is really a problem. And from an occupational, I'm talking about from an occupational point of view, of course, it is, we have to prevent, you know, these healthcare associated infections and microbial resistance. And as you can see it here on the left panel, you have high touch surfaces, which are shown then with some red bricks there. And that is, you know, the contamination of these, you know, surfaces by bacteria. And what happens is that this health-associated microbial resistance is an important issue in healthcare. And in addition to endogenous sources, the high-touch surfaces, such as one shown here, is a source of transmittance of microbes to healthcare professionals. I mean, those who are really handling this. So that's not only a problem of the patient, it is a problem of those who are really handling, you know, these beds and so on. So by coating these surfaces with nanoparticles, such as nanoparticles such as silver, gold, titanium dioxide, or even composites of graphene and silver, one can reduce the transmittance as well as resistance. So this is a kind of really an important issue when, I mean, the health authorities are putting a lot of efforts to prevent bacterial resistance. So we have to think again about the bacterial resistance is also a problem for the workers who are working there. So that is very good that the nanotechnology is also contributing there. But so then the applications in agriculture, as you can see it, I have just listed here too. They can be used as nanofertilizers to increase soil productivity, stimulate plant growth, and also durable and persistent nanopesticides. I mean, that is also an important issue, which is also shown in the right panel. So this will contribute to to more production of food in the area. And I've just included a table here, application food industry. They have a lot of applications in food industry. I'm not going to go through this table, but I will give you my presentation so that you have these tables and those which are not going through. Okay, so all of this is very good. It's about the applications of nanotechnology. So it's a kind of, as Vidar uses to say, it's kind of a Janus phase. It has two phases. We have been talking in the nice phase. That's good. So what about the occupational health concerns? Are there anything? But one thing is that I would like to mention it before I go through the occupational health concerns of these nanomaterials, is that exposure to nanoparticles, at least, it's not new. I mean, it has been. They have been present in nature as like ultrafine particles from volcanic ashes, even sea salt, the forest fire, and biological agents, right, like viruses and so on. So these are known as kind of natural occurring or intentional or incidental nanoparticles. So they have been a part of our natural habitation and civilization of humans for centuries. However, as I was showing you, so this technology is really creating so many different materials, and the likelihood that workers would be exposed to these nanomaterials at workplaces is really high. And it's not only the likelihood of being exposed, but also the amount they are going to be exposed. It's high. So these things are really important. So I will focus on health effects of the manufactured nanomaterials, as I was mentioning them before. So in the workplace, health hazards can result from different exposure routes: inhalation, ingestion, or skin absorption. However, inhalation is considered really to be of the highest concern. And why so? We know that lungs are, they represent an excellent entry portal for nanomaterials, and also they have a huge surface area. And also, we know that there are very thin, epithelial barriers and extensive vasculature, and also so that they will have a kind of connection to the blood circulation. So while dermal and oral exposure may occur, inhalation is more likely to result in a larger systemic dose of manufactured nanomaterials. And here is shown. I should say that most of our knowledge is coming, from the animal studies, and And they have been really, animal studies have been very important, you know, to understand the health effects, the biokinetics, kinetics, and so on. So here in this slide, I'm showing you the effect of grinding in carbon nanotube material and on the dispersion of the CNTs in the lungs. On the upper panel, you can see A and D. It is a rat lung, which has not been exposed to anything. It's the control. On the A, you can see the lung, and the D, it's a microscopic, you know, picture of that lung. And B is the same. The animal has been exposed, you know, to a bulk of these carbon nanotubes. It means they have not been dispersed. So the particle sizes are different and bigger. And you see, as you can see it on the E and also in the B, if you're able to see some, so the particles are mostly, you know, kind of, you know, aggregated or agglomerated in few parts. You know, there's no very even and huge distribution of particles. But on C, the CNTs have been grown, and the particle sizes are really smaller. So you can see that how they are distributed through most of the, you know, area of the lung. So that is that when the particles get smaller, so they distribute more in the lung. So that after inhalation of particles, many of the smallest particles are deposited in the deeper sides of the lung, which are here. Here are the alveoli, and here is the lung, and this you have the inhalation, the particles, and the smallest particles, they get, you know, deposited in the deeper sides. And here is the magnification of this area, which is alveolus. So they get deposited deeper sides of the lung, such as alveoli, and as it's shown in this figure, they react with the lung fluid, as you can see it there. They are also handled by macrophages and processed. You see the macrophages here, they are processed and they are handled, and you have the lung fluid here, which the particles are hitting. But they can be processed. I mean, they can be cleared, the particles can be cleared, but however, if they remain there in the lung, and there is very large likelihood that many of the particles will remain there. So then they can be cleared, with different mechanisms, which I'm not going through that. So the other thing is that the particles can also be translocated from lung to circulation, as you can see it with this, red arrows to the other organs. Translocation to the circulation and to secondary organs here is estimated to be limited to not more than 1% of the mass-based dose. I mean, this is kind of, estimate. And this person estimate is based on extrapolations, from the animal studies. And therefore, we don't have a precise information of biokinetics of inhaled manufactured nanomaterials. And also, we have a very little knowledge about their long-term fate in humans. We know that they can be translocated to most of the organs in the body, but we don't know what are the health effects. So while acute effects from manufactured nanomaterials translocation to secondary organs are likely to be minimal, it is possible that chronically exposed populations may face greater risks from cumulative and low-dose translocation processes. And this chronically exposed population we are talking about, these are people who are really handling these, nanomaterials. I mean, from the design to the end of life, which is the waste handling. So, inhalation, as I mentioned, inhalation of biopersistent nanomaterials, and especially nanofibers, is of great concern. Once in the body, these particles persist for a long time. This slide shows persistence of CNT fiber particles in different organs of mice 1 year after 1 year post-inhalation exposure. And this animal was exposed to two CNTs, a type of CNT, which is called multi-wall carbon nanotube. And you can see them, the arrows, they show, you know, the white bodies, the white things you see there, they are CNTs. You can see them in different, you know, organs like diaphragm, kidney, and even the brain. And you can see it 1 day after exposure, and 1 year or 336 days after the exposure. So they are persistent, and they will be there. So what are the consequences of this persistence? So that, I mean, many of these, based on several animal experiments and, of course, other in vitro mechanistic studies, a working group set up by the World Health Organization's International Agency for Research on Cancer in 2014 in monograph volume 111 evaluated nanomaterials for potential carcinogenicity. So the conclusions were there is inadequate evidence for the carcinogenicity of CNTs or carbon nanotubes. They were focusing on carbon nanotubes at the end in humans because of lack of human cancer data. And that's true. And by today, we don't have those data. The mechanisms reported in animal and in vitro studies are all relevant to humans. And however, a majority did not consider the mechanistic evidence for carcinogenicity, especially concerning chronic endpoints, to be strong for any specific CNT, because in mechanistic studies, in vitro studies, you cannot do long-term, studies. But a type of CNT known as multi-wall carbon nanotube 7 was classified as possibly carcinogenic to humans, group 2B. But the lack of coherent evidence across the various distinct CNTs precluded generalization to other types of CNTs. Therefore, single-wall carbon nanotubes and multi-wall carbon nanotubes other than multi-wall carbon nanotube 7 were categorized as not classified as to their carcinogenicity to humans. Carcinogenicity to humans, group 3. So this is the conclusion from the International for Research on Cancer on the carcinogen effects of the nanomaterials. That's what we have. And of course, some other materials like titanium dioxide and and carbon black, they have been classified by IARC and have been classified, I think, as to group 2B as well. So what about human studies for short-term studies? So there are very few studies that have looked at the human health effects of manufactured nanomaterials at workplaces. A review of such studies was performed by Schulte and colleagues and published this year in 2019 in Scandinavian Journal of Work, Environment and Health. So there are some studies have been published and there are some studies are coming out. And this review, I think it was very nice. And this review was primarily focused on the 9 most widely used nanomaterials identified in the WHO guidelines and is based on the tons of nanomaterials produced annually and used worldwide. These are according to volume produced are carbon black, synthetic amorphous silica, aluminum oxide, barium titanate, titanium dioxide, cerium oxide, zinc oxide, carbon nanotubes, including nanofibers as well, and silver nanoparticles. So the aim of the review was to consider the findings involving human and animal subjects. The animal subjects were also included, and they were used, for mechanistic understanding of the health effects. The systematic review covered studies published for the period 2003 and 2018. So it's a very recent review. I don't know. Yeah, possibly you can see, the findings of the review. So what it was, 500 studies were identified, and after exclusion of many irrelevant studies, 27 human epidemiological studies were included. An important selection criterion for epidemiological studies included was the use of a non-exposed or a comparison group in the study. So they should have had a kind of control group as well. And that was a very important thing. So I show here the summary of the findings in this article. This article is out, and you can have a look on that. There are multiple details on the different things. So as you can see it here, you have the nanomaterial carbon black, which has a kind of 10,000 tons worldwide commercial tonnage, and you have the epidemiological findings, and you have also the potential biomarkers of adverse effects in epidemiological studies, not according to the animal studies, but from the human studies they identified. So as you can see, in the case of pathologic effects, they show changes in lung function values for carbon black and titanium dioxide, and heart rate variability for titanium dioxide, and metal fume fever for zinc oxide. And many of the things are, I believe that they are not, I mean, they are not kind of surprising. So for the, on the case of the, as you can see that there are very few nanomaterials that show kind of pathologic effects in the workers which are exposed to this. But nevertheless, they are showing pathologic effects. In the case of biomarkers, except for aluminum oxide, barium titanate, cerium dioxide, and silver, the nanomaterials led to changes in markers of inflammation, oxidative stress, epigenetic markers of DNA, like DNA methylation, pulmonary and cardiovascular biomarkers, and hematological effects. As you can see it, I mean, from this column here, there are many, or most of the nanomaterials. They're showing a kind of, biomarker of the disease. So these findings show that there is need for further human studies in exposed workers, where the exposure is really determined, and you can classify, group the studies according to biomarkers of exposure, biomarkers of effect. So there is still a need for human studies in this field. Okay, I think I'm done with this part, and I will now go to the, I felt that it was necessary to give this introduction to the nanomaterials and summarize the knowledge, what we know and what we do not know, as Paul was talking here. So, we are talking about this document as it is there. I just, Vladimir and we found that this link is not working. I tried it today, but it was working when I made my presentation. So it is there, it is online. So this is the document which is called WHO Guidelines on protecting workers from potential risks of manufactured nanomaterials. And it was in 2011 that WHO, it is now 8 years ago, initiated the development of WHO guidelines as entitled here, using a systematic evidence review process. This is important, And the aim was to improve occupational safety and to protect health of workers handling nanomaterials in all countries, and especially in low and medium income countries. Low and medium income countries. So a guideline development group, which was chaired by Vladimir, was formed, and here I refer it to as GDG in further slides, was set up along with review teams from different WHO collaborating centers on occupational health, and STAMI as a collaborating center participated with the review team as myself, Vidar Skaug, and Benedicte Mohr. So the target audience of the guidelines includes country ministers of health and labor, occupational safety and health agencies, and professional associations, workers and their employers with premises with a potential risk of exposure to manufactured nanomaterials. And as I say, the focus is on low and middle income countries. And the focus was on the middle and low income countries where nanotechnology is an important means of economic progress. For example, middle income countries such as Brazil and South Africa produce manufacturing nanomaterials and have research laboratories that produce CNTs. However, these countries produce, they also produce nanosilver that is incorporated in milk packs, fabrics and clothes, and M&Ms are also produced for use by the pharmaceutical industry. We know it that there are. However, the implementation of health and safety at work regulations is usually less effective in these countries, which means that workers in these countries are at a greater risk of potential negative health effects than their counterparts in high-income countries. So this is partly because the use of manufacturing is often not known about or well understood, despite the publication of a large number of scientific literature from these countries. So this is the focus is on low and middle income countries. And as I think Vladimir will talk in his presentation, this is not so that the developed countries are excluded. So the GDG identified 11 key issues which are related, which are listed in this table. I'm not going to go through all these questions, but however, they are about risks of the nanomaterials, specific hazard classes, forms and routes of exposure, typical exposure situations, exposure measurement and assessment, occupational exposure limits or OLs, control banding, specific risk mitigation techniques, training for workers to prevent risks from exposure, health surveillance, and also there was initially also a question 3, involvement of workers and their representatives. So, but I think for this question, it was not, there was no literature on that, and therefore, after having these questions, so systematic reviews were assigned to different, systematic review teams, and the findings were summarized and provided as support for the recommendations in the guidelines which I showed there, and using a kind of a grade system. Grade is grading of recommendations, assessment, development, and evaluations. So after the systematic reviews had been conducted, the GDG developed 11 specific recommendations and 3 best practice approaches based on the conclusions of the reviews. Again, I'm emphasizing that these are recommendations. So what I want to do is that go very briefly through these, the recommendations and best practices. One of the best practices that was put forward is the classification of the manufactured nanomaterials. There were 3 best practices. Before I go to this one, I think I will go to the best practice 2-3. I come back to the one, and is education training of workers in health and safety issues, manufactured nanomaterials, involvement of workers in risk assessment and control. The GDG decided that training of workers and work involvement in health and safety issues to be a best practice and not a recommendation. But the GDG cannot recommend one form of training of workers over another or one form of worker involvement over another, owing to the lack of studies available. So I will go back to the one which is one of the important issues, and it is that while we don't have toxicity data for all nanomaterials, what do we do? What should we do about the health effects? So GDG commissioned a systematic review of possibilities to group M&Ms based on toxicological considerations. The systematic review was undertaken by me and Vidar, and we located 20 reviews of grouping manufactured nanomaterials or approaches to transfer hazard information from one nanomaterial to another one. So what we come up here was that we could, just a moment, I have to move to my, so what we did was that finally we had to modify our question so that the question was not the review of the literature on grouping, but the expert opinions. So that the GDG considers it in the final, this is the conclusion from GDG, that it's best practice to class nanomaterials into 3 groups. They manufactured nanomaterials with specific toxicity, and in this group you have the again 2 groups. It is higher solubility particles like quantum dots, like zinc oxide, copper oxide, and so on. And then you have poorly soluble and high toxicity particles like crystalline silica, nickel oxide, and chromium oxide. And then the second group was respirable fibers. And in this group, you have carbon nanotubes and nanofibers that fall under the definition of WHO fibers. It means that they have a length of more than 5 micrometer and diameter of 3 micrometer, and the length to diameter, which is called aspect ratio, should be 3:1. And these materials are called as like high aspect ratio nanomaterials or harms, and nowadays they are also called as high aspect ratio materials generally, so harm. And the group 3 is granular biopersistent particles, GBP, also known as poorly soluble low toxicity particles, titanium dioxide, carbon black, and also what is interesting to mention here is that shorter fibers that are not classified as WHO fibers can fall into this group. And I went through the best practice 2 and 3, and I would like to go through this, the specific recommendations. After the systematic, as I mentioned, so 11 specific recommendations were put forward or in the guidelines, but the quality of evidence for the various recommendations varied, and that is the So when assessing the overall quality of the evidence, there was either high quality, it means that there is further research, further research is very unlikely to change the confidence in the estimate of the effect. Moderate quality further research is likely to have an important impact on the confidence in the estimate of effect and may change the estimate. Low quality further research is very likely to have an important impact on the confidence in the estimate of effect and is likely to change the estimate. Very low quality, any estimate of effect is uncertain. So then the recommendations were also whether strong, the quality of evidence combined with certainty about the values, preferences, benefits, and feasibility of the recommendation means it should be carried out in most circumstances. And then you had the conditional recommendations that's saying that there was less certainty about the combined quality of the evidence and values, preferences, benefits, and feasibility of the recommendation, meaning there may be circumstances or settings in which it will not apply. So, the recommendations or the strength and were not only based on the on the scientific review or findings. But there are other things, I mean, values, preferences, and so on, that you can read more about in the guidelines. So, the recommendations assess health hazards of the manufactured nanomaterials. GDG, it's recommendation number 1, recommends assigning hazard classes to all manufactured nanomaterials according to the globally harmonized system. It means that the GHS, the UN's GHS system for classification and labeling of the chemicals for use in safety data sheets. For a limited number of M&Ms, this information is made available in these guidelines. And I will come back to that question again for that, I mean, the classification. I think it's an important issue. The GDG recommends updating safety data sheets with M&M specific hazard information or indicating which toxicological endpoints did not have adequate testing available. For both of these recommendations, they are strong and there is moderate quality evidence for these two. And then you have for the respirable fibers and granular biopersistent particle groups, the GDG suggests using the available classifications of M&Ms used in GHS for provisional classification of nanomaterials of the same group. So what is this GHS classification we are talking about? What was shown is that there was a systematic review which went through the hazard classes that can be assigned to specific manufactured nanomaterials, and I think it was the Korean review team, so that they evaluated many of these nanomaterials that were in the OECD, that they had OECD dossier. As you can see it from this table, I don't know if you can, sorry. As you can see it from this table, so a selected list of nanomaterials was considered, and the most common hazard classes assigned to the M&Ms, as you can see it from there, it is specific target organ toxicity after repeated exposure carcinogenicity. As you can see, they have been categorized in different categories. Category 1, it is the GHS category 1, which is, what is category 1, is usually implies serious and or irreversible damages. So this is category 1. For example, for single-wall carbon nanotubes, for the specific organ toxicity, it was a category 1, while the evidence which was found there was low evidence. And for the carcinogenicity, it was based on the IR class 3, group 3, as I was mentioning earlier. It is not classifiable. But for the germ cell mutagenicity, it was category C, category 2B. And category 2B in the GHS is milder or reversible damage, and within A category, B is even milder damage. Within each category can be A or B. For multiple carbon nanotubes, it was found that it could be categorized as category 1 by the GHS system, and it was medium quality evidence, while for the carcinogenesis, it was the same as the IR classification. For germ cell mutagenicity, it was category 2 with high evidence, high quality evidence, and for the eye damage, it was category 2A. For the nanosilvers, nanosilver, so it was category 1, but of course, it should be the route of exposure is important. It means it should be by inhalation. And for oral exposure, it was category 2 with high evidence, both of them. And for gold, it was found only for the specific target organ toxicity. It means for category 1. The same was for the silica, which is category 2 by inhalation. titanium dioxide and cerium oxide, they were found to be in category 1 by inhalation, and the evidence is high. For zinc oxide, again, it was found that it was category 1, and no other effects were found. As I was mentioning, again, titanium dioxide has been classified as group 2B carcinogen by IARC, and also category 2 with low evidence from the GHS. Okay, so I think the time is running, and I'm not going to go through all of these guidelines. These two were the most, important, findings, and they made, the basis for the other things. And also, of course, they had guidelines on to assess the exposure to M&Ms. Here they had there were 3 recommendations. All of 3 were conditional. With low quality evidence, but one thing is to mention here is for dermal exposure assessment, there was insufficient evidence to recommend one method of dermal exposure assessment over another one. So dermal exposure is debatable. So here are the OLs which were found in the review, which is included in the guidelines document. You can have a look on that, and also you can have my presentation where I have summarized the OLs. The same is the review which was published on the exposure assessment and measurement, published by Debia et al. In 2017. Controlling the exposure to nanomaterials. Here there were 5 recommendations. 3 of them were strong with moderate quality evidence, and 2 of them were conditional with low quality evidence. So I think I will skip all of this. And health surveillance, which is a discussion and debate on that. So 7 studies were found. 1 study described a program but did not report any health outcomes. And this review was undertaken by the group from South Africa, Mary Gulloman and so on, and colleagues. So the conclusion from this was that GDG cannot make a recommendation for targeted manufacturing and specific health surveillance programs over existing health surveillance programs that are already in use owing to the lack of evidence. So they are not going to, they have not recommended a specific surveillance program for nanomaterials other than its existing. So the focus of the recommendation is specific recommendations to 1 to 3 aim to define specific nanomaterials and their health hazards, as I was showing you. Recommendations 4, 5, and 6 focus on assessing exposures that impact on workers' health and safety, and recommendations 7 to 11 focus on interventions that are generally used to protect workers' health. Implementation of the guidelines. So, given the importance of this, so Vladimir is going to talk about that, but there. At least, the GDG, it seems says that it's important, to implement the guidelines, specifically on the LMI countries. Updating will come, at least that was planned. I don't know what's the status now in 2020. And thank you for your attention. And I think you were really, I see the faces, so like this, but there will be a break right after me. And thank you for the reviewer team, myself, Vidar, Benedicte, and also many thanks to Nina Landvik and Joss Ferbik, who contributed to our publication on the grouping of the nanomaterials. As Paul was mentioning, it is out publicly. Thank you very much.
Thank you, Shan, for your presentation. Now we will have a short break. There should be some snacks available in the hall. And please be back in 15 minutes.
And precisely 15 minutes.
Velkommen igjen. Vi må gå videre. Så nå presenterte vi da guidelines. Og så... Oh, sorry. Sorry, you see that now. Sorry, Vladimir. So I presented the guidelines and the main, lines. And as you know, and I was saying that they are meant for regulatory, purposes. So they are not for research. So it's therefore we invited Chief Engineer Astrid Lund Ramstad from Norwegian Labor Inspection Authority, which is the competent authority regarding the occupational health aspects and safety in Norway, to give their thoughts on the guidelines, what they think, and what is the significance possibly of these guidelines, in Norway, in relation to Norway, regarding the nanosafety of the nanomaterials. So, Astrid, the floor is yours, please.
Thank you very much. Thank you very much for your introduction and for the invitation to speak on this seminar. It's always a pleasure to take part on an event at STAMI. And actually, this year we can celebrate 10 years anniversary with STAMI for collaborating regarding nano issues. I will shortly present the Norwegian Labour Inspection Authority, our vision, objectives and instruments, and the importance to work for achieve a safe and healthy working environment, which is important for all issues, also regarding nanomaterials. I will then continue with safe handling of nanomaterials, news on REACH, and give some thoughts about the significance of Labour Inspection Authority guidelines on the manufactured nanomaterials compared to guidelines from WHO, and then mention collaboration in Norway. The Norwegian Labour Inspection Authority is a governmental agency under the Ministry of Labour. We have a central office in Trondheim and 7 regional offices. We are just in a process of reorganization, so I'm not sure how map I can show you next time. We are about 600 employees and about 400 inspectors that check the conditions around in Norwegian enterprises. And the primary focus is on occupational safety and health, and we focus on private sector as well as public sectors, and cover all land-based operations with employees. The agency's overall objective is a healthy working environment for all, with a secure and safe employment conditions. It should be safe to work in Norway. We work to ensure that the enterprise works systematically in compliance with laws and regulations. And we aim to be visible and use experience and knowledge to influence the state and standard of working life. We also aim to prevent illness and injuries caused by your work. We have several instruments to get enterprises to work, to work systematically with their own work environment. Our main tasks are inspections, supervisions, guidance, and we are a promise provider, such as participating in adoptions of existing regulation and new regulation. We also collaborate with others, such as other authorities, the social partners, and STAMI, as I mentioned. We supervise through inspections, but we also give extensive guidance and knowledge about the Act's requirements. And small and medium-sized enterprises, as well as those who are new in the priority target groups for the labor inspection, especially when it comes to guidance. And for the nano issues, we primarily guidance in our activities. By working systematic with the work environment, you can prevent illness and injury, and in the worst, deaths due to your job. Systematic health and safety work is thus the method of preventing in a good way. So, for the enterprises, we address the importance of working systematically with their own work environment. The need for having an overview of the work environment and having a good and open dialogue with your employees. It's about being ahead, start to organize the work, identifying risk, and react before something suddenly can happen in the work environment. This is a continuous process, and it should be a natural part of the enterprise. A regular routine has to be repeated regularly. It's the employer that is responsible for the work environment. The employer shall ensure systematic monitoring of the regulatory requirements of NIOSH in its activities in the enterprise. And this is to be done in collaboration with the employees and then their representatives. The employer shall take the initiative to motivate and facilitate the introduction to systematic HSE work and follow up the work. And so the employees have both the right and the obligation to actively participate in the work environment. In the case of nanomaterials, and to work systematically with the work environment, we recommend 3 steps for safe handling of nanomaterials. And this handling procedure was made through a 3-party collaboration and also with STAMI and the university. First, to prevent exposure to nanomaterials is about working systematic with NIOSH, and it's best done by identifying hazards, carry out risk assessment to identify and assess exposure, and to measures to determine and implement measures to reduce the exposure. We guide in safe handling on nanomaterials by a precautionary 3 steps approach for reducing risks and ensure safe handling of nanomaterials. We recommend first to identify materials to be considered as nanomaterials by chemical and physical properties. We divide nanomaterials by type, and we divide nanomaterials by physical states, and identify materials and products where risk assessment is to be carried out. The Labour Inspectorate has created a step-by-step recipe for how to risk assess the handling of nanomaterials. First, it's to find out if the nanomaterial is classified as a carcinogenic, mutagenic, or reprotoxic substance. Then to define the physical state of the nanomaterial, according to known possible health risks. We have divided into 3 different hazard classes. For instance, water-soluble nanoparticles is hazard class 1. Less soluble particles, metals and metal oxides, class 2, and fiber forms and insoluble nanomaterials as class 3. And to search for possible exposure to nanomaterials in the working environment by 3 different exposure classes. And in the 3rd step, we recommend to determine and implement measures to reduce the exposure. So, what actions has the company initiated to reduce the exposure in the workplace? Is it possible to replace hazardous nanomaterials with less dangerous materials? What processes can be changed in order to reduce the exposure? And how can work be reorganized or made differently so that the personal exposure is reduced? And what personal protective equipment is necessary when the above measures are implemented? This step is due to the STOP hierarchy: substitute, technical solutions, organizational, and personal protective equipment. As for other chemicals, the Working Environment Act, the internal control regulations, the different working regulations, REACH and CLP regulate and is applicable for manufactured nanomaterials. Whereas today, occupational exposure levels do not regulate nanomaterials. For chemicals without an OEL, we recommend consider the information available for the substance in accordance to the company's internal criteria for acceptable exposure. Such information may be other countries and organizational OELs for the substances. And we recommend proposed OELs for a selection of nanomaterials. In order to better regulate the nanomaterials under REACH, the annexes to REACH have been adopted. And the date of entry into force is 1st of January 2020 and will be implemented in the Norwegian REACH regulation. There is then a need for updating the REACH guidance documents from ECHA. And the Environmental Agency and the Labor Inspection Authority are both taking part in the partner experts groups for consultation on the update of the existing guidance documents. And STAMI will give and has already given inputs to those documents. Annex 2 is now being revised in order to take into account the changes from the globally harmonized systems. So, requirements for the safety data sheets related to nanomaterials are to be adjusted, and it's just under progress now. Shan mentioned the definition, the REACH definition in details. And this is, you don't need to read this, and you was given a detailed summary from Shan. But here is the definition from 2011, but with the adoptions. So we see that a nanomaterial is defined as a nanoform, and we group nanoforms characterized into a set of similar nanoforms. And there are also added requirements for the characterization, which will be challenging for the industries because this will be very expensive. There are all these characterization methods available. I will now give some thoughts of the significance of WHO's guidelines on manufactured nanomaterials by comparing the Labor Inspection Authority guidelines from 2014, with the WHO guidelines. Labor Inspection Authority recommendations for assessing health hazards have parts of and contains the same recommendations given by WHO. In accordance to the global harmonized system, we need to carry on by recommending assigning hazard classes to all manufactured nanomaterials. So more details have to be given here. Safety data sheets help workers to safely manage chemical substances and inform about hazards that may be present in the workplace. And this is also the case for nanomaterials. In accordance with input to the revised Annex 2, different forms of substance, for example, nanoforms, relevant information shall be included in the safety data sheet of the substance and or a mixture. So the text in this red box is implemented in the Annex 2 of REACH. And this is in accordance with the recommendations from WHO. Updating the safety data sheets with manufactured nanomaterials specific hazard information. And the latter sentence or indicating toxicological endpoints not available for adequate testing. And the latter part of the sentence is important. And on the other hand, the guidance document from REACH will describe human health endpoints. And the last point is the same. Suggest using the available classification of manufactured nanomaterials for provisional classification of nanomaterials of the same group. In order to assess exposure to manufactured nanomaterials, we recommend to assess whether workplace exposure exceeds a proposed OEE, occupational exposure level value, and in accordance with WHO's recommendations. For manufactured nanomaterials where there are no OELs, the enterprise must assess available information and reach criteria for acceptable exposure. Such information may be the proposed occupational exposure limits and toxicological data of other countries and organizations for similar substances. And WHO recommended if specific OELs for manufactured nanomaterials are not available in the workplace, do a stepwise approach for inhalation exposure. And that's done by an assessment of the potential of exposure, conducting basic exposure assessment, and conducting comprehensive exposure assessment due to OECD. And this is partly taken into account in our first point, the criteria for acceptable exposure. For control of exposure, we advise in accordance with WHO's recommendations, using a precautionary approach. The three first points are equal, and we recommend to prevent inhalation exposure to free particles or aerosols by occupational hygiene measures by using a mask with the particulate filters or a breathing apparatus. And to prevent dermal exposure, here we have similar recommendations. WHO recommended and suggest using control banding to select exposure control measures in the workplace. When it comes to health surveillance and training and involvement of workers, first, for the health surveillance, we provide appropriate health examinations as consultations together with a corporate health service, if the worker can be exposed to potentially hazardous manufactured nanomaterials. And the training and involvement is in accordance with the regulation for chemicals. In addition, labor inspection recommend a register including employees that can be exposed to nanomaterials. This is meant to be a preventive measures required to possible negative health consequences. So employers should consider having a register for potential exposed workers. To sum up, we can see that the Norwegian Labour Inspection Authority has largely congruent guidelines as with WHO by using a precautionary approach. And this is in order to reduce exposure, since it's uncertainty about the health impacts. We guide in best practice. We guide the workers in safe handling of nanomaterials. And the nanomaterials are grouped based on specific toxicity, the three hazard classes I mentioned before. In Norway, we have a good collaborating working with nano issues. And back in 2009, the Nano Group, led by STAMI, started their job. And still ongoing activities are to keep up-to-date knowledge on health risks, follow the research, follow adaptations and give input to the EU regulations, keep an eye with nanoproducts and quanta, and workers that might be exposed to nanomaterials. And at the moment, the group consists of staff from STAMI and from the Labor Inspection Authority, and the Environmental Agency has joined the group, and they is consulted when it regards to the regulations. In 2070, we established a Norwegian legal network for nanomaterials that is led by the Norwegian Environment Agency. And the main focus is in this group is to share information and use on subjects on nano issues that the agencies are working with in their area. And for your information, please have a look at our websites for the nano issue and the 3 steps for safe handling of nanomaterials and routines for handling these materials. And for questions, please contact us. Thank you for your attention.
Thank you, Astrid, for your presentation. Now it's time for a new break. It should be some fruit available in the hall, and please be back 12 o'clock precisely.
We will continue with another interesting presentation, and it is really, really my pleasure to introduce to you Dr. Vladimir Murashov from National Institute of Occupational Safety and Health, NIOSH, who was the chairman of this guidelines development steering group, and we met in several occasions during the development of these guidelines. And he has, in addition to this, he has quite authoritative knowledge on exposures and other things, so don't hesitate to talk to him during the lunch and after this, and ask him the questions that I think he would be able to question better the questions than myself regarding these, regulated things and exposures. So it is a really great pleasure for me that he accepted our invitation and come over the Atlantic here to talk about the importance of the development guidelines. And I think you're going to focus on the implementation part of these guidelines and comparing them with the US regulations and globally. Something which is similar to what Astrid did in relation to the importance and of the guidelines for the Norwegian work environment regarding the nanomaterials. So, Vladimir, floor is yours. Thank you.
Okay, thank you, Shan. Definitely thank you for inviting me here. It's a great pleasure to be here. And thank you for making my first trip to Norway possible. So as Shan said, I will be talking mostly about implementation of WHO guidelines today. But I will start by a very brief introduction of institute that I work for, the National Institute of Occupational Safety and Health. Then the main part of the presentation about the implementation of the guidelines, and then I will finish just describing specifically how guidelines align with regulation in the US. So very briefly, how regulation of workplace safety is done in the US. I think it's quite similar to Norway. We have the research agency, which is NIOSH, which is the sole federal government agency tasked with conducting research, developing training materials, and developing recommendation for workplace safety. NIOSH is located in the Department of Health and Human Services. Regulation is done by the Department of Labor, and in the Department of Labor there are two agencies. One dealing with mine safety is MSHA, and the other one dealing with all the other industries is OSHA. So my institute, NOSHA, was created in 1970, and it was mandated by the Occupational Safety and Health Act to produce criteria identifying toxic substances, provide criteria so that no employee will suffer material impairment of health, and finally to explore new problems created by new technology, and clearly nanotechnology would fall under that clause in the law. So when nanotechnology became popular, we created a horizontal organization within our institute. It's called Nanotechnology Research Center, which is a virtual center. It was chartered in 2004. It brings together around 90 scientists across the institute. It was quite productive. It published over 1,200 papers. It developed several private-public partnerships with companies and universities, and also we collaborate very extensively with other government agencies just to make sure that we utilize our resources most effectively. My institute provides global leadership on occupational safety and health for nanomaterials by collaborating and leadership in government-level international organizations such as United Nations institutes and Organization for Economic Cooperation and Development. We also participate in development of international standards. Specifically, we lead Working Group 3 on nanomaterial safety in International Organization for Standardization, and we're also actively involved with ASTM International. And we also participate in multi-stakeholder ad hoc groups. And one of the more recent examples of such groups is the US-EU non-EHS communities of research. So there is lots of work done by several international organizations on nanomaterial safety. Luckily, the work on chemical safety, including nanomaterial safety, is coordinated among international government-level organizations through the Intergovernmental Program for Management of Chemicals, or IOMC, shown in the square here. This umbrella organization coordinates work on chemical safety and nanomaterial safety, and it includes International Labour Organization, United Nations Environmental Program, United Nations Institute for Training and Research, the World Health Organization, the Food and Agriculture Organization, and the OECD. So the nano work is mostly done right now by WHO, FAO, UNITAR, and OECD. And then there is a direct highest level liaison between OECD Working Party on Manufactured Nanomaterials and the ISO TC229, which is developing standards for nanomaterials. So again, the work is fairly tightly coordinated, even between the International Voluntary Standards Organization, the ISO, and the IOMC. And then ad hoc groups, they contribute indirectly or directly to the work of international government level organizations, and also they contribute to the work of ISO TC229. So our engagement with the WHO is quite similar to the engagement of STAMI. That is, we are a member of the global network of 55 WHO collaborating centers that the director of STAMI mentioned this morning. This is the institutions that carry out activities to assist WHO and to improve global worker health. And now this brings me to the second part of my presentation, is the WHO guidelines for nanomaterials in the workplace. And I will start here by briefly describing WHO mandate and how it relates to workplace safety and how it relates to nanomaterials, then give a very brief summary of the guidelines, and then focus and spend more time on guideline implementation. So the WHO mandate, it has authority to direct and coordinate health within the United Nations system. WHO mandate includes providing leadership on global health matters. It's also mandated to shape the public health research agenda. And it's represented in 6 world regions, including Europe. Presently, United Nations is working to address 17 so-called sustainable development goals. Of these 17 sustainable development goals, 3 are directly related to the workplace safety. The first one is to eliminate poverty. The third sustainable development goal is to ensure good health and well-being of everybody, including workers. And the 8th sustainable development goal is to ensure that everybody has access to decent work and economic growth. So why WHO started looking at nanomaterials? It recognized that nanotechnology and nanomaterials is emerging technology with increasing use patterns. Risks of nanomaterials are not fully evaluated, and there is a need for assessment of available evidence and for application of prudent approaches to nanomaterials. The technology is used worldwide, but information is not available in an equal and equitable manner. There is a need to provide the same level of protection for workers dealing with nanomaterials across the world. And global science-based guidelines which WHO can develop can ensure appropriate health protection activities in a wide range of countries around the world. So here's more specific rationale for WHO nano guidelines. Again, production processes for nanomaterials often take place in low and medium income countries. There is insufficient health information for specific nanomaterials, but at the same time, there is enough information to provide interim recommendations and guidance about approaches to nanomaterials handling in the workplace. WHO also recognized that there are existing guidelines for nanomaterial safety developed by other organizations. For example, there are a series developed on nanomaterial safety developed by Organization for Economic Cooperation and Development. There are a number of standards developed by ISO, but often these documents are not universally applied, especially for low and medium income countries due to a number of barriers. For example, OECD's include 34 member countries, high income countries, and some of the low and middle income countries not always utilize documents developed by OECD, again, for a number of reasons, political, economical, and so on. And the ISO standards, though, should be more widely accepted, but at the same time, they have their own issues. For example, they are not freely available. You have to buy them, and the cost can be quite high. So that's certainly a barrier, even for us in the high-income countries. Okay, and another rationale for WHO nano guidelines was it was recognition that it was a good opportunity to develop first occupational safety and health guideline in WHO. Development of guidelines for nanotechnology aligns well with commitment from WHO to look at the safety in the workplace. Specifically, one of the resolutions adopted at the World Health Assembly on worker health, I think in 2015, was under Objective 2 to protect and promote health at the workplace. Here there is a sub-objective 11, which states that the assessment and management of health risks at the workplace should be improved by health impact assessments of new technologies, work processes, and products at the design stage. Again, nanotechnology clearly would fall under this sub-objective. So now moving on to the WHO guidelines. The initial project proposal for development of these guidelines in WHO, I think, was in 2010. So it took 7 years to develop these guidelines, so that they were finally published in December 2017. And they should be, and they were available at this link, but I think they have some technical issues right now. NIOSH contribution to these guidelines was, as Shan already mentioned, we provided leadership for the guideline development group. There was also an internal WHO steering group there where we participated as well. We did one of the 10 systematic reviews on controlled benzene, just like STAMI did on hazard categorization of nanomaterials. And we also provided expertise of some of our scientists who critically reviewed final recommendations given in these guidelines. So this is just a brief summary of guideline recommendation. As Shan already said, there were 3 best practice statements and 10 or 11 recommendations arranged around assessment of health hazards, assessment of exposures, and then providing recommendations on how to control exposures. So once the guidelines were published at the end of 2017, the guideline development group effectively converted into guideline implementation group and started working on the second phase for the guidelines, the guideline implementation phase. Here you see a summary of the action that the guideline implementation group is doing, which are shown in green color, and in black are shown potential future activities by the guideline implementation group. So just I will briefly describe each of these activities, starting with translating to other languages. Very recently, on March 12th of this year, Canadian Institute for Occupational Safety and Health, IRSST, translated guidelines to French, and they are available now. And I think there is also work underway right now in Brazil to translate to Portuguese. And hopefully there will be more translations as time goes by. The next activity that the guideline implementation group did last year was to work on integrating recommendations of the WHO guidelines into training courses on nanosafety. So here, what we did is a United Nations Institute for Training and Research offered for 3 years online e-learning course on nanomaterial safety, and that was done in 2013, 14, and 15. And then in 2018, government of Malaysia approached UNITAR and asked if UNITAR could convert online course into in-person, face-to-face, week-long training course. And that was done in November 2018 when we were converting online course into face-to-face course. We updated the material, but we also included information and recommendations from the WHO guidelines. So in that sense, that training already incorporates the WHO guidelines on nanomaterial safety. And we can do it, again, depending on the interest of other governments in other countries. Next activity is providing and disseminating information about the guidelines through a number of channels, such as web communication. And here, WHO did a number of infographics, such as this one. This particular infographics is just describing what nanomaterials are. They also have infographics on the guidelines. Next one is disseminating information about the guidelines through conference presentations. Again, we did a number of presentations. One of the recent ones was done in October of last year by our technical expert, Jos Verbeek, which Shan already mentioned today. He did a presentation about these guidelines at the OECD expert meeting. So when we were doing presentations about WHO guidelines, one of the feedback that we received from the audience was, well, how do these guideline recommendations translate into legislative actions in European Union or in the US? And in response to that type of questions, the guideline implementation group decided to develop a table very similar to what was presented earlier. So on the left in this table, we put WHO, specific WHO guideline recommendations. Then the second column is the corresponding European Union legal requirements, and then the last column, US legal requirements. And we did it for all of the WHO recommendations. Next action that guideline implementation group was working on is developing safety data sheets for nanomaterials in collaboration with WHO ILO International Chemical Safety Cards Program and the United Nations Globally Harmonized System on Communication and Labeling of Chemicals. So I don't know if you're familiar with the International Chemical Safety Cards, but it's a joint program between World Health Organization and International Labor Organization. The goal is to prepare and make available simple workplace-oriented hazard communication tools on chemicals. They can assist in implementing globally harmonized system on classification and labeling of chemicals, or GHS. They are intended to complement but not to replace the safety data sheets. They are more concise, they are less complex, they are more authoritative because the international chemical safety cards are developed through international peer review process as opposed to be prepared by the manufacturers. At the same time, they don't have legal status. So as Sean already mentioned, one of the recommendations of the guidelines is to assign hazard class to manufactured nanomaterials according to GHS. So clearly there is a mandate to continue working on adjusting GHS to properly address nanomaterials and nanomaterial safety. As a result of the publication of these guidelines, now the group in WHO, which is responsible for maintaining international chemical safety cards, at their last meeting, they decided to start working on developing international chemical safety cards for nano forms of chemicals, starting with 3 pilot substances, the titanium dioxide, zinc oxide, and one more substance to be determined. Most likely it will be a cerium dioxide. So next we'll move on to describe some of the ideas about what guideline implementation group could do next. Starting with developing a corporate governance document. And here the idea was inspired by the corporate governance document developed and available from the OECD. And in that case, this particular guidance document is aimed at senior leaders in high hazard industries. In particular, I believe this one is for the chemical industries. And similar document could be developed maybe jointly between WHO and the OECD, aimed at senior leaders in industries which manufacturing and utilizing nanomaterials. Next idea is to develop a list of practical tools for guideline implementation. There is lots of work done in different countries and different organizations, STAMI and NIOSH, which could be used, which could form a basis for such a list of practical tools at WHO. And I'll just show one example is developed by my institute, by NIOSH. We have a series on workplace design solutions, and we have them available. It's just a very easy to read 2-pagers documents aimed at improving workplace safety for specific workplace situations where nanomaterials are being handled. So this one, the first one is protecting workers during nanomaterial reactor operations. Next one is protecting workers during handling of nanomaterials. And the third one is protecting workers during intermediate and downstream processing of nanomaterials. So again, this is just one example. It's freely available from NIOSH website. And I'm sure there are lots of similar type of materials from other organizations, including STAMI. This is another example developed by my institute. It's a poster which guides through a series of questions. Again, the ultimate goal is to make recommendations to a particular workplace on what would be the most appropriate engineering controls to make sure that the workers are protected. Okay, next potential activity by the guideline implementation group is assessing the use of nanomaterials in countries. Again, there's lots of activities that have been done already in that field. One example is nanomaterial registries. I think the first nanomaterial registry was put into force in France in 2013. Then in 2015, 2 countries started requiring registration of nanomaterials, Denmark and Norway, I believe. And then most recently, Sweden in February 2019 started requiring declaration of nanomaterials. So this can be used as foundation for the similar activities in WHO. The next possible activity by the guideline implementation group is providing real-world examples on the use of hazard information and proposed occupational exposure limits in countries and in different workplaces. Lots of work done again in this field, which could form a basis for WHO actions. Example from my institute is we have a so-called field team for nanotechnology, and that field team conducted over 100 visits to 65 different sites. This field team look at the diversity of manufacturing sites, diversity of nanomaterials and applications. We have one focused effort looking at carbon nanotubes and carbon nanofibers, mostly because of high hazard of some of these carbon nanotubes. And we also had a focused effort looking at the effectiveness of different engineering controls to reduce exposure to manufactured nanomaterials. During this type of visits, the field team would go to the site, evaluate processes and personal exposures utilizing state-of-the-science, state-of-the-art equipment, which is often inaccessible in the field by the companies themselves. We have to do it collaboratively in partnerships with the private sector, as we are a research agency. We don't have any regulatory authority, so if we are not invited, we can't go anywhere. Our experience shows that the private industry does trust us, and they do invite us quite frequently. The outcome of this field team visit would be we develop recommendations for that particular work site on how they can improve their workplace safety. And also our interest in this is that we use that field information to move forward the science. So we do publish all of these results in open literature. One example is shown on this slide. In 2015, NIOSH published a summary of control evaluations at 3 carbonaceous nanomaterial plants. And we have a lot more publications from field team. And we will continue with this effort at least through 2025. In our new strategic plan, the very first activity goal is prioritize high volume emerging engineered nanomaterials to identify candidates for field evaluation of workplace exposures. All right, so that brings me to the last part of my talk, which is implementation of the guidelines in the US. And in this part, I will describe present OSHA guidance for nanomaterials and also how WHO guideline recommendations align with the US legal requirements. So OSHA has a dedicated nanomaterials web page, which provides overview of what nanotechnology is and what nanomaterials are. And then it describes how US legal requirements apply to nanomaterials and nanotechnology. Specifically, it states that presently there are no specific legal requirements for nanomaterials, but existing legal requirements may apply to nanomaterials, starting with the so-called general duty clause. The general duty clause requires employers to furnish to each of his employees employment and a place of employment which are free from recognized hazards. So the keyword here is recognized hazards. So if there is information available about hazardous nature of nanomaterials, then employers would have to do something to minimize risks of those nanomaterials in the workplace. And then there are also other existing regulations which may apply in particular situations where employees are exposed to nanomaterials. Here's just some examples: recording and reporting occupational injuries and illness, use of personal protective equipment, eye and face protection, respiratory protection, hand protection, sanitation, hazard communication, occupational exposure to hazard chemicals in laboratories, and certain substance-specific regulations, such as regulation of cadmium. Now moving to the how US legal requirements align with WHO recommendations. Starting with the first one. Assign hazard classes to all manufactured nanomaterials according to the globally harmonized systems of classification and labeling of chemicals for use in the safety data sheets. And the second one, update safety data sheets with nanomaterial specific hazard information or indicating which toxicological endpoints did not have adequate testing. These two WHO recommendations align quite well with US legal requirements, which is OSHA hazard communication standard, which requires classification of hazards according to GHS. Since GHS right now doesn't specifically call out nanomaterials, then the US legal requirements in this particular place also don't call out specifically nanomaterials. The next WHO recommendation deals with read across, use the available classification of nanomaterials for provisional classification of nanomaterials of the same group for respirable fibers and granular biopersistent particle groups. And presently there are no legal requirements for read across, whether for chemicals or for nanomaterials. The next WHO recommendation is assess work exposure in workplaces with methods similar to those used for the proposed specific occupational exposure limits for nanomaterials. And again, there are no specific legal requirements for nanomaterials right now. Because there are no specific regulatory OEL values for nanomaterials in workplaces, assess whether workplace exposure exceeds the proposed OEL value for nanomaterials. In the US, there are very few mandatory occupational exposure limits that are specific to manufactured nanomaterials, and those are for so-called traditional nanomaterials, synthetic graphite and carbon black, two of those type of so-called traditional nanomaterials. The next WHO recommendation, if specific OELs for nanomaterials are not available in workplaces, use a stepwise approach to assess inhalation exposure. And in this case, there are no specific legal requirements in the US for a stepwise approach for chemicals or for nanomaterials. So the next two recommendations deal with controlling of exposure, specifically inhalation exposure. And here there are two relevant legal requirements in the US. One is the general duty clause, which belongs to OSHA, if you wish. And then the second legal requirement belongs to US Environmental Protection Agency, which has limited authority to regulate workplace safety. So the EPA has legal authority to determine that the use of chemical substance is a significant new use. And the interesting part here is that under this authority, EPA can require for manufacturers or for users of chemicals or nanomaterials to use respirator as a protection in the workplace for person who is reasonably likely to be exposed to the chemical substance by inhalation. So as of March 21st of this year, EPA issued 39 significant new use rules specifically for nanomaterials. Here's one example of such significant new use for a nanomaterial. And this particular significant new use rule is for siloxane modified silicon nanoparticles. And in the lower part of this slide, you can see the specific language of this requirement. The EPA requires for the use of NIOSH approved respirator with a approved protection factor of at least 10 to 25 to be able to work with this particular nanomaterial. Okay, next recommendation, WHO recommendation deals with in the absence of toxicological information, implement the highest level of controls to prevent workers from any exposure. When more information is available, to take a more tailored approach. Here, the most relevant US legal requirement is again the general duty clause. Next WHO recommendation deals with the application of the hierarchy of controls. And here there is US legal requirements described in this 1910.1000E, which states that to achieve compliance with the previous paragraphs, administrative or engineering controls must first be determined and implemented whenever feasible. When such controls are not feasible to achieve full compliance, protective equipment or any other protective measures shall be used to keep the exposures of employees to air contaminants within the limits prescribed in this section. So US does have legal requirements to use a hierarchy of controls for hazardous materials, including nanomaterials. Next WHO recommendation deals with dermal exposures, and there are applicable legal requirements in the US, eye and face protection, hand protection, sanitation. So those are general chemical safety type requirements. They are not nanomaterial specific. Next WHO recommendation: when assessment of and measurement by a workplace safety expert is not available, use control banding for nanomaterials to select exposure control measures in the workplace. In the US, there is no specific regulation about control banding, but the general duty clause would work in this case as well. Next WHO recommendation deals with health surveillance, and we already heard about that. It doesn't recommend a nanomaterial specific health surveillance program, and similarly in the US there is no specific requirement for health surveillance for nanomaterials, but there are specific regulations on health surveillance for specific occupational hazards such as cadmium already mentioned. In that regulation there would be a specific health surveillance requirements. So if cadmium would be in nanoscale or cadmium would be in a nanomaterial, then that legal requirement would kick in. Next WHO recommendation is the guideline development group considers training of workers and worker involvement in health and safety issues to be best practice, but cannot recommend one form of training of worker over another. Again, this is quite consistent to what we have in the US. There is a US legal requirement that employers shall provide employees with effective information and training on hazardous chemicals, and that would include nanomaterials if they are recognized as such in their work area at the time of their initial assessment. Okay, that brings me to my last slide. I guess I went very fast, which is global role of WHO nanomaterial guidelines. So these are just some of my thoughts on the role of this particular WHO guidelines. These guidelines would act as a soft law. They don't have legal authority directly from WHO. They will only start having legal authority when they adopt it at the national level. But given the broad respect and adoption of WHO guidelines in general, we can expect similar to happen with WHO nanomaterial guidelines, and we already see some examples of that happening. We just saw today how it translates in additional recommendations from legal authority in Norway. Definitely one of the major role that I see of these guidelines in improving safety and health of workers handling nanomaterials globally is they raise global awareness of occupational risks of nanomaterials, and therefore they definitely contribute to strengthen the notion that hazardous nanomaterials are recognized hazards, and then that would facilitate the enforcement of the general duty clause or its equivalents in other countries around the world. The WHO guidelines for nanomaterial safety are already having a role in improving safety data sheets for nanomaterials, making sure that they are adequate and they do address and reflect hazards of nanomaterials, not their parent chemical. And these guidelines already started to affect further development of globally harmonized system of classification and labeling in adjusting them to address nanomaterial safety. WHO guidelines for nanomaterials will provide practical tools to reduce risks of nanomaterial in the workplace based on the experiences in different countries. But once those experiences rise up to the level of WHO, once they post it on WHO webpage, they again will become much more widely adopted. And finally, I think these guidelines will have a long legacy because these are the first World Health Organization guideline for workplace safety. These guidelines created effectively a roadmap for addressing occupational risks of emerging technologies when they come. So with that, I thank you for your attention.
Thank you, Vladimir.
I've reached to the next stage, and this is, I think, before lunch. Here we don't have any break, and it's the section for questions and possibly answers. So since we have Vladimir is here, so I think we can start with questions to Vladimir, and then you can also ask questions for the other sections that I and Astrid presented. Yes? It's open for the questions. Yeah.
Thank you for the wonderful presentation. My name is Abdul Qadir Suleiman. I work with the Norwegian Labour Inspection Authority. So with Astrid. My question is, some of the recommendations prerequisite regulatory framework in order to be applicable or to be applied. Are the guidelines when they were prepared, was this taken into consideration that a regulatory framework has to be available for these guidelines to be applicable?
I don't think so. And the reason for that is these guidelines were developed based on scientific information about hazards of nanomaterials, exposure to nanomaterials, and what control measures are effective to minimize risk to these nanomaterials. So they are based on what we know about nanomaterials and risks in the workplace. We couldn't really take into account specific legislative frameworks because within United Nations system there are 196 countries, and I think we couldn't possibly do that. Another reason that it wouldn't be appropriate for WHO guideline to start from that end is because there is also an International Labour Organization which deals with regulatory issues of workplace safety, and because, well, it would be more appropriate for the ILO to look at that part of this equation, if you wish. So that's a brief answer. So look at this way. WHO is more like STAMI, and ILO is more like the Norwegian Inspection Authority. So just like STAMI develops science-based recommendations for inspection authority, and then inspection authority take them on and modify their regulations or legal framework as appropriate, is the same way WHO deals with workplace safety and ILO. So I don't know if that answered your question. Or... Okay.
More questions to Vladimir? Yeah.
Thank you for a very nice overview and a summary of the work that has been done. I have one detailed question. It relates to the handling of chemicals through the hierarchy of controls. You state that one should use the whole range of the hierarchy of controls, and that is in concert with which was proposed by the Norwegian authorities. But my question is, how detailed can you go? Perhaps by definition, you have to run through the whole hierarchy of controls for chemicals and also for nanomaterials. But my question to you is, would you think it's appropriate to stop before using protective equipment, respirators? Is it possible to not include respirators when you're considering the hierarchy of controls? That is, to not use the whole scale.
Right. In the ideal world, I think we could avoid using respiratory protection, but I think in the real world, I don't think we can avoid this in all possible workplace scenarios. And that's a short answer.
Yeah, I think I agree. It's the you can never protect oneself, especially dealing with nanomaterials. They're all the way, and I mean, people don't want to use respirators. It's a problem. It's a really big problem if you could avoid it. But as of today, I think also I agree that one should use the whole scale and not stop before using respiratory protection.
That's very interesting, question. I mean, using these PPEs or especially the respirators, and there was this very interesting project that we were part of that project and funded by Norwegian Research Council. I mean, looking at the so-called, mask fitting, how it fits, and how the workers really, if they want to use it, because I mean, it's not really comfortable for them. And then also you have to design many types of the respirators which fit really to their face and they are comfortable and so on. So that project was funded by Norwegian Research Council, and it was they were looking at the respirators in the Norwegian smelter industry. So there is one PhD dissertation in Tromsø. I think it is on 21st of May. Considering exactly this type of, the question of, but they are looking at the, I mean, not the fit testing, but also the human psychology. And that's a very interesting aspect that I think needs to be investigated more. More questions for Vladimir while he's standing here? I was wondering that you talked about the when you compared the how the US regulation versus, I mean, the recommendations from WHO. What about the EU regulations? And are there any European efforts, you know, to look at these matters, and European efforts, you know, to for implementation of these guidelines? I mean, I think Norway has started with this meeting, with this nano seminar, and trying to at least, I mean, show that this these guidelines could be something, you know, to work with and to better the nano safety of the workers in Norway. But what about the other EU countries?
Yeah, so this is the second part of the work that WHO guideline implementation group started working on, which is comparing EU regulation for nanomaterial in the workplace and WHO recommendations. So this is like for the first one, assign hazard classes to all nanomaterials according to GHS. There is a CLP regulation which applies to substances or mixtures manufactured or imported. Classifications should be done for each nanoform. REACH doesn't apply if the tonnage is less than 1 per year, except for substances which have carcinogenic, mutagenic, toxic for reproduction, persistent or biopersistent. Then for the next WHO recommendation, which is updating safety data sheets with nanomaterial specific hazard information, the same US regulation would apply. For read across, there is a REACH, this regulation which supports reading across. Next one is assess workers' exposure in workplaces with methods similar to those used for proposed specific occupational exposure limits. In this case, there are no specific EU legal requirements. The same for the next WHO recommendation. There is no specific occupational exposure limits in the European Union for manufactured nanomaterials. If specific oils for nanomaterials are not available in workplaces, use a stepwise approach to assess inhalation exposure. The applicable EU requirement would utilize the European Union standard measurement of exposure by inhalation of nano-object and their aggregates and agglomerates. Focus control of exposure on preventing inhalation exposure with the aim of reducing it as much as possible. EU Directive 89/391 on health and safety at work recommends to reduce exposure to levels that are reasonably practicable. Next, WHO recommendation, reduce exposures to a range of manufactured nanomaterials that have been consistently measured in workplaces, especially during cleaning and maintenance. There is an applicable EU directive, though it's not specific to nanomaterials. Next one is, in the absence of toxicological information, use preventative measures to minimize or reduce any exposure. And EU Directive 98/24 on protection of workers from the risk related to chemical agents establishes that the employer shall carry out risk assessment on those substances that are dangerous. So again, this is a general EU requirement, not specific to nanomaterials. The next one about hierarchy of controls, similarly a general EU legal requirement for chemical safety. For dermal exposures, there is a specific EU directive on the use of PPEs, including PPE for dermal protection, not nanomaterial specific. For control banding, there is no specific EU regulation for control banding or for nanomaterials, but Article 7 of EU 89/391 legal requirement state that the employer shall designate competent persons to carry out activities related to the protection and prevention of workers. So no specific nanomaterial requirements, and I don't see specific calling out of control benzene. For health surveillance, there is specific health surveillance requirements, but not specific to nanomaterials. And then for training, there is relevant EU article on training of workers, not specific to nanomaterials again. So that's it.
It seems that, I mean, in EU there are already some, legal, regulations are in place. So and it was in the talk by Astrid also, you could see it. I mean, most of the elements that they are in the guidelines, they are already in place. I mean, in the regulatory, guidelines or vad heter det, forskrifter eller något sånt. So I mean, the question is whether are really these guidelines. I mean, the Europe or EU or the other European countries, they really see any, added value of these guidelines, the original guidelines, and maybe they are hesitating. I mean, because there are some regulations in place to implement these guidelines.
Yeah, I think and I already stated that I think the main value of these guidelines is the contribution to the notion that some nanomaterials are recognized hazards. And then that would kick in already existing regulations which are already in place.
You comment something, Astrid, or?
These EU directives are implemented in the Norwegian laws and regulation, but they cope in general with chemicals, not specific on nanomaterials, but with REACH and the adoption, it will take more, it's given more attention than to regulate the nanomaterials, because we see it's a challenge to actually regulate these materials.
Anybody in the audience, they see if this is, if really these guidelines are important or not? Many of you are working with, with regulating this, or you may have concerns about, the exposure to nanomaterials in that workplace. Okay, they are valuable, they are okay. Yeah. Yes.
Okay. I think it's very valuable that it's an WHO recommendation, because, as you said, it is. I don't know how much problem or how much manufacturing there is of actual nanoparticles in the European Union or the USA. So I guess a bulk of the manufacturing will be in low or medium income countries, and that's where WHO is one of the main contributors, I think. So it's very good that actually it comes from the WHO.
The question is, do you see any trends, or any activities, except the one you mentioned, was it in Malaysia maybe, or no? It was not.
Yeah, Malaysia.
Yes. Are there any activities on the governmental level?
Yeah,
where they're trying to implement, or yeah?
Yeah, there is definitely increasing level of interest from my personal experiences, Malaysia, but then there is even Vietnam, Philippines, Thailand, South Africa that you mentioned already. At least in those countries, there is a definitely increasing level of interest in non-material safety.
And then you mentioning this as a kind of soft law, how it interprets. It's interpreted in the low and medium income countries.
Well, the way it works is it kind of nudges, if you wish, the national authorities to start doing something about it. But I also wanted to just one more comment as a follow-up to the gentleman. introduction is I think it's also these guidelines are relevant for high-income countries, even though, like you correctly stated, there's not that many nanomaterials are manufactured in high-income countries, but the processing of incorporation of nanomaterials in final products, and as well as working with the products at different life stages of non-enabled products does take place in high-income countries. So it's and these guidelines would apply to those situations as well. And that was I think one of the reasons why when the guideline development group was working on these guidelines, there were quite a few comments from participants from high-income countries who were saying, well, why are we saying that it's only for low and medium income countries? It should be for all countries. These guidelines are useful for high-income countries as well. So.
Yes, and I think one of the things that when we were working with this the nano group, and as Astrid was mentioning, is that, you know, I mean, the import of nanomaterials, maybe it has a kind of, you know, high volume, so they're importing even though they are not producing it. And of course, I mean, could be somehow also a matter of, because we are moving to this, you know, I think they are being used, you know, in many aspects, as I was mentioning there. Yeah. More questions to all of us three? No, everything was clear. You're hungry, maybe? Yeah, good. Yeah, I think then we are ahead of the schedule, 25 minutes. But I don't know what's the program after that. Then I think.
Thank you. Yes, now lunch is soon available in the canteen, 15 minutes. So I would like to thank all of you for coming here today and all of you following us online. Thank you. Would you like to say something, Shan?
I would like to thank all of you that you wanted to come, and also thank you for those who are following us on the net. And very many thanks to Vladimir for coming over here. Very good. And Astrid for a nice presentation, really. So thank you very much.